Hi, everyone. Thank you for attending today's live session as part of the AOCS Industry Update. My name is Andrew Lee, and I'm the Senior R&D Manager of Food Protection Team at Kalsec. The title for today's presentation is Clean Label Food Protection Strategies, Dual Functional and Synergistic Food Preservation System with DuraShield Natural Food Protection Blends. DuraShield blends were introduced last year in the market, and as the title suggests, the product is a dual functional, meaning that it protects food products from both oxidative, spoilage, and microbial spoilage in a combined solution, and also captures the synergistic antimicrobial effect to effectively solve these complex spoilage issues and extend product shelf life and improve safety. So I will talk about those in much more details throughout the presentation. Today's agenda will be as follows. It will start with an introduction and common quality defects affected by oxidation, as well as microbial spoilage and food safety. And lastly, clean label shelf life extension, accompanied with case studies. And I'll close this session with the Q&A. So when it comes to food and beverages, there are different types of spoilage issues that limit product shelf life. And this could be due to lipid fat oxidation, microbial spoilage, or both, depending on the final application. Therefore, it is important to understand the limiting factor of shelf life in specific food categories and apply the appropriate solutions. Now, when it comes to food spoilage due to oxidation, the oxidized food product could have various issues, such as off flavor and aroma, color degradation, change in protein functionality and texture, and loss of nutrients. To extend shelf life by protecting foods from being oxidized, Kalsec offers a wide range of natural antioxidants, including rosemary, mixed copperol, ascorbic acid, acerola cherry, citric acid, and green tea. Among these different types of antioxidants, Kalsec has been a pioneer when it comes to rosemary, from being vertically integrated and optimizing its antioxidant efficacy by standardizing its active components. We leveraged our own rosemary expertise and used it as one of the key building blocks for DuraShield food protection blends. Now, for our internal research and for the development as well as to best support our customers, we've established various tools and techniques to measure the level of oxidation in a food system. Our capabilities include, but not limited to, using Oxipress or OSI for accelerated testing, and GC mass spec and GC olfactometry for more of the analytical part. Of course, human nose could be more sensitive than any other instrument in certain cases, and therefore, we leverage our internal expert sensory panels when it comes to oxidation management. Now, switching gears, I will talk about the other side of the food spoilage, that are microbial spoilage, as well as food safety. As a matter of fact, the #1 cause of food recalls is microbial contamination. Also, 48 million people get sick due to foodborne illnesses every year. And approximately 25% of food waste and loss is due to microbial spoilage. The common characteristics due to microbial spoilage are off flavor, aroma, change in color, change in texture, and or gas production. From Kalsec, we provide an antimicrobial as a concept of providing additional hurdle for microorganisms to grow. So for example, if they're able to overcome the intrinsic and extrinsic hurdles such as temperature, water activity, pH, and redox potential, our approach is to provide a clean label natural preservative that serves as an additional hurdle to prevent the microorganisms from further growing. As mentioned earlier in the title and the introduction, we are leveraging our existing capabilities of antioxidant expertise including our rosemary and other building blocks, and we combine it with our natural antimicrobials, including cultured dextrose and buffer vinegar, that are all produced from a natural fermentation process. And by combining these solutions in a specific way, we come up with our DuraShield natural food protection blends that are synergistic and dual functional. Since cultured dextrose is one of our key building blocks for the DuraShield food protection blends, I would like to go into a little more detail of our cultured dextrose. Cultured dextrose is a cultured food ingredient, and it is basically a sugar fermented by microorganisms that are generally recognized as safe. And these include mainly lactic acid bacteria and propionic acid bacteria that are not very different from microorganisms that are found in traditional fermented foods. So a common misconception of a cultured dextrose is that the product may taste sweet because of the word dextrose. However, since those dextrose or sugar are utilized by these microorganisms and consumed by them, there is no longer sweetness remaining at the final product. Due to the fermentation and by capturing the whole metabolites of the fermentation, cultured dextrose is a mixture of antimicrobial peptides, so-called bacteriocins, organic acids, and other metabolites. Due to multiple different types of metabolites that are present in cultured dextrose, they have multiple mode of action coming from bacteriocins, organic acids, and other low molecular weight compounds. Also, the product is very versatile. It has a wide application range as well as broad antimicrobial spectrum. Since it is a fermented product, also it could serve as a flavor enhancer to the final application, imparting savory and umami notes. Now, with our new product and with our laboratory in Kalsec, we have developed quite a capability when it comes to antimicrobial. That includes expertise in microbial physiology, food microbiology, and capable of handling biosafety level 1 and 2 microorganisms, including pathogens, thanks to the dedicated BSL-2 laboratory at Kalsec. Also, we leverage on traditional microbial culture, utilizing selective and differential media, as well as advanced molecular biology tools, such as real-time qPCR, when we would like to specifically monitor a given microorganism in real time. Kalsec manages antimicrobial projects using various tools and matrices, anywhere from a simple in vitro system to a more complex food application. In vitro assays are relatively high throughput and used as an initial screening tool to assess antimicrobial efficacy. Our antimicrobial team routinely performs microbial profiling using plate counts and DNA sequencing tools to identify the dominant spoilage microorganism in a spoiled food. This allows us to work with relevant microbes and recommend the best solution. Lastly, our microbiologists are experts in performing challenge studies to test the antimicrobial efficacy of our solutions in real applications using our own developed model system or closely collaborating with different types of food manufacturers. So this was end of the introduction, talking about the product as well as the capability. And now I would like to move on to our actual case studies and see how the DuraShield performs in different applications. So we'll start with the food protection solutions for meat and poultry and different protein applications. So the first case study I would like to introduce is done in our fresh ground turkey model system. And this time we were leveraging on the inherent microorganisms growing naturally in the fresh ground turkey. So if you look at the control, which is the red line, it starts from a 3 log CFU per gram total plate count. And you can see that it quickly grows up to 7 log CFU per gram within 10 days. Now, with our DuraShield solution, you can see that the growth was effectively inhibited by all the product lines. Now, there were some interesting differences, so I will go into a little more detail about that. But first of all, if you look at the other treatments, the blue line, which is 1% PV, P stands for our cultured dextrose, and B stands for our buffer vinegar. Also, N stands for our rosemary extract. So if you look at the green line treatment, which is a 1% NPV, it's a combination of rosemary, cultured dextrose, buffer vinegar in a specific ratio. Now, the interesting part is when you compare the green line, NPV, versus the PV, the blue line, the only difference in the treatment is a slight amount of rosemary added to the final product. However, you can see there's a much better trend of microbial inhibition with the NPV treatment, which is the green line. So our scientists were interested to take this to further consideration to look into what exactly is the dominant spoilage microorganism in a ground turkey, as well as is there any specific synergistic effect coming from these different ingredients. So in this slide, you are looking at an in vitro study to test for synergy. But before that, when we isolated the dominant microorganisms, the most dominant microorganism turned out to be Pseudomonas. Now, by taking a single colony and putting in an in vitro system, we were able to test for synergy. So for example, the top left graph you're looking at, we test the synergy between the buffer vinegar, which is V, and the cultured dextrose, that is P, the green bar. Now, when those were used in a specific concentration, given below, for the buffer vinegar at 0.044%, we were only seeing 36.8% of gross inhibition compared to the red bar, which is the control. Now, for the cultured dextrose, we were also seeing only 3.9% inhibition at a given concentration for Pseudomonas. Interestingly, when we were combining those two solutions at the same concentration, we were seeing 99.6% inhibition, confirming a synergistic effect. Similarly, when we were testing rosemary and cultured dextrose, they were also showing synergistic effect. However, not in the treatment with vinegar and rosemary, since they were only showing additive or somewhat antagonistic effect in this system, particularly for Pseudomonas. Now, moving on to a next case study. This study, the objective was to test the efficacy of DuraShield against Listeria monocytogenes in cooked chicken breast. Now, the interesting comparison will be the light green line, which is the DuraLox NB, that are the combination of rosemary and vinegar, and versus the NPV, a combination of rosemary, cultured dextrose, and vinegar. So 0.5% DuraLox NB was also still somewhat effective in inhibiting the growth of Listeria compared to the growth control, which is the red line. However, if you compare the 0.5% NPV versus the DuraLox NB, the addition of cultured dextrose was showing combination and synergistic effect compared to the green line. So you can see the light blue line was more effective than the NB. Now at 1% NPV, which used a similar amount of vinegar compared to the 0.5% NB, it was showing complete inhibition throughout the shelf life. Now, earlier we talked about the DuraShield food protection blends were dual functional, meaning that it also has an antioxidant effect coming from rosemary. So we were interested in testing the efficacy of DuraShield for protecting the cooked chicken model against oxidation. So this time we were monitoring the accumulation of headspace aldehydes, which is a common breakdown molecule from lipid oxidation. And when you compare the control versus the DuraLox treatment, you can see that at day 4, DuraShield NP and DuraShield NPV was more effective and was able to effectively inhibit the accumulation of headspace aldehydes compared to the control. Now, when it comes to a product and product development, we also consider flavor as a very important parameter, since it should not negatively impact the flavor of a final application. So here we test the 1% of DuraShields that are the higher concentration we will recommend in a cooked chicken patty, which is very plain and not having any background spices. As a result, the incorporation of DuraShield blends did not affect the flavor and aroma profile of the cooked chicken. and only showed very minimal impact on the herbal load. So overall, it was having a minimal or a somewhat pleasant effect at the final application. Now, moving on, I would like to briefly talk about our applications in alternative meat, which is also a very emerging food category. And here, we were also interested in the performance of DuraShields against microbial spoilage, as well as testing for its antimicrobial efficacy when it comes to synergistic effect. So here, there's two objectives, again. First of all, testing the efficacy overall against spoilage organisms, but also we wanted to compare our rosemary and cultured dextrose blend versus just cultured dextrose alone. And again, the NP2 is a different type of cultured dextrose being used. So you can compare the NP2 versus P2. And just a disclaimer that we don't sell cultured dextrose alone. We just sell our synergistic and dual functional blends. So P and P2 are not a commercial product for Kalsec. So now moving on to the data, this was a total plate count. And starting from the control, you can see that control started off from 2.5 log CFU and had a slight lagging phase up to day 7, where all the treatments got similar count at day 7. But it quickly grew up to 8 log in an exponential phase within day 20. So you can see that the control was being spoiled significantly. Now, the interesting part will be comparing the NP2 versus the P2. So compare the orange line versus the blue line. And you can see that the NP2, which was much more effective compared to P2 at the end of the shelf life. And the only difference was a slight addition of rosemary. Now, NP and P performed overall pretty well. But again, there was a slight trend that the NP was keeping the count lower compared to the cultured dextrose treatment alone. Now, for yeast and mold, for this particular application, there was not a significant yeast and mold spoilage, since you can see only a log growth was appearing from the yeast and mold count throughout the shelf life. However, again, there was an interesting trend that the P and P2, so without the rosemary, it was slightly showing growth up to 1 log CFU. However, the DuraShield NP2 and NP were all kept below the limit of detection, so only showing less than 2 log CFU per gram overall, and confirming that there's also a synergistic effect. Again, going to the sensory data, we were seeing that the DuraShield was positively impacting the savory aroma and flavor, in addition to their existing savory note coming from the base protein. However, the overall flavor impact was minimal or very slight on the savory flavor. Now, I'll close the presentation with just introducing our capability. So for that, in today's presentation, we've looked at complex shelf life challenges that could limit the shelf life of various food applications and strategies to effectively control and manage shelf life with using DuraShield natural food protection blends. Now, as a closing remark, I would like to introduce our core food protection team at Kalsec, composed of meat scientists, microbiologists, food chemists, and alternative protein scientists that could help to optimize your product shelf life. Thank you for listening, and I'll be happy to answer any questions.